Hello, good morning or afternoon, as we probably are now for you all. So my name is Paul Thomas, as was introduced. I just want to say thank you very much for the invitation to allow us to take part this morning and give you a little bit of an insight to what's happening with regards to AI in the video security market. And to do that, I'm here to press the buttons to allow my colleague, Dr. Rob Dupré, to give you a good, very good and in-depth presentation about what we do, how we're doing it, and where we see the market moving and moving forward. So with that, I'll hand over to Rob.
Yeah, hello everyone. Thanks, Paul. So yeah, absolutely. As Paul said, the sort of goal here is quite a quick summary, really, on some of the sort of technologies that we employ. So a little bit of background on us. We're a company called VCA Technology. We're based in the UK. And we have an analytics toolbox, which we call VCA Server. And that is basically an application that can take in camera, IP camera, RTSP streams, run our analytics on it, and generate some sort of metadata. And we've been doing this for about 12 to 13 years. Going all the way back from sort of what we would call kind of traditional machine learning based techniques, so things like motion detection, all the way up to what now is kind of termed AI, but really is kind of a deep learning based solution, and how we apply those. So I'll give a very quick summary on some of the technologies that we use and how we use them. What you'll see from us, certainly as a company that's been doing it for a while, is that these sort of technologies aren't what you'll see at the very forefront of AI. That kind of stuff will take a few years to get to a point where we can viably deploy that at the edge. So for us, what we're looking at is how do we get solutions that can be run on your site, because we're still at a stage where trying to get video up to the cloud en masse isn't necessarily viable. Even with things like 5G and the inevitable release of 6G, we're still not quite there in terms of bandwidth. So having the ability to do video processing on site is still, very much the sort of form that we find it. And so what you won't see here is things like, large scale LLMs or multimodal LLM technologies being applied, because at the moment, it's not realistic to do that on a kind of cost per channel perspective. So as I said, we've been around for a long time. We have approximately 2.5 million, probably closer to 3 million channels of our analytics running. So that's either IP cameras that are running our analytics within the camera itself, or servers that are pulling the camera streams in and processing them on that server technology. We tend to work in three areas. Security has been the biggest part of our business since we started, but we have. And what you'll see is a lot of the technologies that we implement have a lot of crossover with other applications like traffic management or retail business intelligence types applications. So you'll see when we're doing things like object tracking, whether you're tracking a person or a vehicle or people in a store, the base technologies are actually very similar, and the outputs also apply in many applications. So you'll see a sort of overlap with that. As I said, for us, we specialize in on-edge inference and tracking solutions. That's not to say that cloud-based inference is not viable, but what we find for security specifically is when you're looking at, I need an event in real time, actually realistically that still needs to be done on the edge because of communication transfer times and various other kind of impacts that mean I need a result as quickly as possible. Okay, so when we're talking about AI and security, for us, there are sort of three objectives, and this is how we divide the types of outputs our systems provide. So as I mentioned, real-time events is probably fundamentally the most important. So that is things like, there is a person in this zone, there is a person in my car park, for example. There's the metadata generation side of that, and that's sort of a newer area where, outside of a rule-based alarm, this is the sort of aggregation of metadata over time to allow us to do retrospective searches. And I'll show an example of a system that we use to do that. And then again, more recently is probably the reporting insight side of that. So if you consider the sort of real-time events and the metadata as the base level of your kind of analytics output, reporting and insight will be your aggregation of that data to provide. Could be insight about how you're applying your security technologies. It could be real-time dashboarding. It could be that you have a secondary level of AI looking at trying to determine how better to optimize, how you deploy your security staff, or how you deploy analytics. So we'll go into detail on all of these real-time events. So this is about really kind of rule-based alarms. So this thing is happening now and we need something about it. So at a very basic security level, we find a lot of our customers are involved in kind of remote visual monitoring solutions, and that is, if you've got a site, a store, or a car dealership, for example, and you need to monitor that overnight, what you'll typically have is a security guard who's looking at a kind of video wall of 20 or 30 screens and looking for if something suspicious is happening. And what AI at the edge for your real-time events is doing is basically allowing another set of eyes on all of those cameras all of the time to alert that security guard that something is happening and they need to kind of review that. So that is, person crossing over my fence. It could be there's a fight taking place. It could be more basic things about not necessarily something that fundamentally needs to be actioned straight away, but it could be, okay, there's more than 6 people in the zone. That's something indicative of maybe a crowding or an overcrowding event. And so, it's about generating that event to kind of as a pre-warning solution. So we'll talk a few little examples of this. This is fundamentally what we would normally present as a demonstration of our kind of tracking technology. So this is actually a video based in Oxford in the UK. It's actually a video from a common machine learning data set. And it's a good way of kind of looking at what you can detect and how you detect it. And this is a tracking solution that we have called our deep learning object tracker. It detects various types of people and objects, and then obviously identifies those people between the frames. So using this, we can say, there's a person in the zone, they've been there for a certain amount of time, they're traveling in a certain direction. We can apply things like speed or size filters on it. So it's really a kind of base level metadata that we understand about a particular video stream that we can then apply our rules to. And this is sort of best case scenario. It's a nice bright scene. It's very clear what's happening. This is actually what we normally have to deal with. So security and AI has been around for a while. And so what you'll find is that there are cameras that have been installed 10 or 15 years ago. In this case, the lens is distorted. It could be that the lens itself has suffered UV damage. It could be there's an IR light that's kind of focused on it and causing problems. It could be that it's raining or it's snowy. And so this is the kind of real requirement that you actually have from a kind of security sterile zone detection environment. It could be that someone's put the cheapest possible camera in, but they still want to know whether or not that person is there at that particular time. So we looked at things like the tracking side of things. We mentioned some of the other kind of events, real-time events that you might need. One of the ones that we're seeing more often in the industry now is kind of behavior-based analytics. So this is things like fall detection, and this is kind of a use case around lone worker protection. So if you've got a situation where you've got someone who's working on their own, it could be that they've got a convenience store in the US, for example, there's one person. It could be that there's somebody working on a remote engineering role and there's an accident and we want to have some sort of indication that maybe something's happened to the person and they're not in a position to raise the alarm themselves. By extension of that, again, around that kind of US market, obviously things like hands up detection is a relevant use case that we have now. And that's not necessarily just as an early warning that something is happening, but this kind of technology can be used to allow the person who's working in the store to raise a sort of silent alarm. So this would allow them to look at the camera, put their hands up in a sort of relatively innocuous way, generate an alert inside the system, and then that system can maybe pre-alert a security guard or again a central monitoring center, and something where a human can have some input. Another one around the behavior is, of course, aggressive behavior. And so this is a technology that we've developed for kind of one-on-one fighting detection. So this isn't something we would apply in sort of large-scale crowds. This isn't a sort of riot or mass issue. This is really about kind of one-on-one fights or two-on-two. Again, looking at that kind of lone worker, sort of smaller kind of number of people here. So we've looked at sort of the sort of obvious security applications, but the other side of that can also be around kind of monitoring of people, and in this case we have a solution called accessory detection, which is really about PPE. So we're looking here at the detection and presence of high visibility vests and hard hats. So there's a couple of applications for this. We developed it around something called access control, which is basically the ability to say, you know, in the case of a warehouse, you have a person coming in to go to work. They want to know that that person has got their high vis jacket on and they've got their hard hat on, and maybe not allow entry into the warehouse unless both of those pieces of equipment are seen. Obviously, as part of a sort of monitoring solution, if they take off their hard hat or they take off their jacket, then again a real-time alert can be raised. And also in the warehousing solution, we also have things like forklift detection. So if you've got a forklift going around, we can detect its speed. We know that maybe a forklift is moving. Perhaps we would want to raise an alarm if there's a person within a certain area, and again as a warning to say, you know, the forklift or the person shouldn't be there, or the forklift's moving too fast. So again, it's not necessarily always about the immediate alarm. It could be that it's a preventative based technology. We want to make sure that that person doesn't go into that zone while the forklift is moving, and it could be that we're triggering lights or some sort of panel to say or provide warning to the people in the warehouse that this thing is happening, and maybe you don't want to go into that zone. Likewise, so this is another solution we have called color detection, and again, this is really kind of does exactly what it says on the tin. Again, around that rules solution, so rules for us we can combine together. So whether or not there's a person or a vehicle in a zone, for example, can be one component of it. But actually, often you want to combine multiple elements into a single alarm. So here we have a red light that's going off. It's almost imperceptible in this video. But obviously, as the light goes off, the barrier comes down. And in this particular case, we have a lorry who's not stopped. And as a result, we can generate a dangerous crossing alarm because we know that that person or that vehicle shouldn't have crossed at that time. So again, with real-time events, we're looking potentially to combine information from lots of different sources. And so in this case, we're looking at both the light and of course the presence and movement of a vehicle in the scene. So lastly, on the real-time eventing side of things, so again, when we're thinking about security, we can also be talking about you know, unlawful behavior. So this is a technology that we've developed to look at how people interact with self-service checkouts. And so in this kind of solution, we'd be looking to combine the visual element and the data that we produce from the vision, also into the self-checkouts point of sale terminal data. So whether or not scans are happening and what's being scanned. And so in this case, we're looking at our rules. We're saying if an object has gone into the scanning area and into the bagging area, that would be a valid item. But if we're seeing an item go directly into the bagging area, that could be some sort of suspicious behavior. And it could be that we want to notify the staff member in the store to potentially have a look at that transaction. Maybe somebody's just put a bag in there and that's fine. If we see sort of multiple of those, then it could be that the person is attempting to steal something. And again, we can kind of combine that information with the terminal information to give us, you know, a more robust system. So that kind of covers high level what we do in terms of real-time events and the kind of AI and security around that. Meta generation is probably the biggest change we've seen in the last few years, and this is really kind of as a result of if I'm running all these algorithms all the time to look for a particular event, so I'm looking for the person to enter the zone, I have to be processing that information all the time to detect whether the persons are there and where they are and if they're in that zone. The metadata generation side of that is really the ability to kind of take that information and store it. So whether or not you have a particular rule or not, I can now do a retrospective search. I can say, okay, in the last 24 hours, show me all the people that had a red bag, for example, or show me when there was a person in this particular camera, or even show me all the people who look similar in my store over the last 4 hours, so I can get a view on maybe where someone has gone. If I've lost a child, for example, maybe I can upload an image and look for all the people that are similar, and then maybe hopefully find them much quicker. And there's a demo of this here. So in this particular setup, we have about 5 cameras connected. We've done a search using our metadata. Here we're looking for a person with a red bag. And now we've found the person of interest. We can basically create a profile for that person, like a similarity search. So whereas traditionally you might have gone, okay, I'm looking for the person with the blue trousers and the flowery top. Flowery top is a very difficult thing for us to kind of define as a sort of search parameter. And so what this does is we use a solution called what we call re-ID, and it basically kind of encodes all of this information, the color information, the sort of shape information, the texture information, and allows us to then find all of the people that look similar, both across color, texture, and size. So here we're creating a little profile of that person. We're then defining where we want to search. So it could be a time period and the number of cameras. We do the search, and now we should be looking for all the people who match that kind of similarity metric across all of the cameras. So if this was a lost child, for example, we would now be able to look through all the examples. We now know, which cameras they were detected at what sort of time, and of course we can play back the video from this, and we can see, okay, well, they were in camera 4 and they've left to the left, for example. And so as a result, it provides a way of reviewing a large amount of video data very quickly. Because if you've got, say, 5 or 6 cameras and you're looking in an hour period, you could be that you need to review manually 5 hours of footage, which obviously takes, even if you're sort of twice speed, 2.5 to maybe 3 hours. So again, it's about leveraging this information that we were already producing as a result of, is there a person, if we're doing, say, crowd counting, or we're looking at the number of people entering or exit the store, this is kind of leveraging all that additional data that we were already generating to kind of add a little bit more value in terms of providing a search solution. Okay, and lastly, the reporting and insight side of things. So this is really about looking at the outputs of both your eventing and your metadata. And as with any report, kind of provide that in a sort of human consumable method to allow you to sort of action that data at a high level. So that could be from a shop or a retail insight. It could be things like the current occupancy. That could be because you want to know from a business intelligence standpoint what kind of business you're doing from day to day. It could be that from a security and evacuation standpoint, you know that there's roughly 20 or 30 people. If you're only getting 10 or 5 people out, maybe something's happened, or maybe there's a door that's locked or a particular blockage. So again, providing a bit more information. So James, in the previous example, was talking about situation awareness. Again, this is a good example of the metadata that's already generating information and providing a bit more data at a higher level. Talking a bit more about the retail side of things, and we see this information being applied a lot more in the retail space. It could be things like areas of high interaction. So that could be, if you're looking at marketing and so on, it could be that you're saying, okay, this area of the store is where most people spend their time. It could be that's where we need to target our marketing. It could also be from a security standpoint, okay, this is where we see the most amount of attention from, say, midday to 2 o'clock. Maybe that's where we need to station our security guard to provide the best kind of visual coverage to the members of staff or the customers that are using it, to provide kind of the most impact from your security guard. It could, of course, be from a high level retrospective standpoint in terms of, okay, if I'm looking at maybe slip and fall events or people walking in the wrong direction, for example, I could be looking at the number of incidents and again trying to target whether or not that is, now I know it's happening, do I again put a security guard or a resource there? Do I potentially look at how the store or my museum is laid out to try and better inform the customer or the person about where it should be, or prevent that kind of situation happening? Typically, this information will be provided in a dashboard. So I've got a couple of examples from other companies. These aren't ours, but again, it's sort of representing good use cases. So dashboarding and reporting can be a real-time thing. So if we look at the bottom right here, we're looking at things like the occupancy, who they are, age and gender. So again, around that retail space, it could be looking at using this information to help resource, okay, we've got over 100 people, that's our benchmark to say have 2 security guards as opposed to 1, or I'm looking to have more people on my terminals to kind of generate customer business. It can be from that sort of real-time view. And then, as I said, it can, of course, be there around the sort of incident management things. So what is the breakdown of my incidents? It could be that if I'm doing that across stores, for example, or across sites. Do I have a big problem in the US with certain types of falls, for example? Is that a flooring problem? So again, it's providing a bit more information outside that kind of real-time event that's happened and I need to action it, to okay, we've got a bigger problem here because we're having loads of this particular type of incident, and we can see that, we can see when it went up. Could be that that correlates to some change we had in the store. Could be that it's some sort of some sort of outside reason, but we now have something to kind of register that as a problem. Okay, I think that covers the sort of three main areas. Thank you very much for your attention, and yeah, if there's any questions, I'd be very happy to answer them.
Great. Thank you, gentlemen, very much. And we have one question in chat. Do you see it? Maybe you can open.
Let me go to my, I'll try and find it. It's got this sort of, let me stop presenting and then I can see it. When do you think AI will be optimal for daily use on cameras, or is it already optimal? Because you said that AI could recognize hands up, but I could already see it happening when I make up hands up as a joke. It could trigger the security measure, for example, alert the police. Yeah, absolutely, and it's a really good question. So, yes, certainly AI on camera is definitely an area that we see all the time, and the jump over the last few years about the on-edge computation capability has gone up significantly. So a lot of the algorithms that rerun on server will indeed run on camera, and that has a number of advantages in terms of the deployment architecture and the cost. If you're buying a camera, you pay a bit more, and now you have your analytics running on the camera. There's no need for a server. That kind of stuff can be quite efficient. And of course, from an architecture standpoint, it means that if one camera goes down, I don't lose the analytics for the store or the site. And so there's a sort of independent backup side of things there that's really helpful. Your false alarms is absolutely another aspect to be considering. There are in some cases things that you can't do about that. So this is a really good example. If you're running hands up and you've got people in store kind of doing it and triggering those alarms, if the analytic is working, then it should trigger that alarm and it should generate that issue, which of course is a problem from the security standpoint. And so a lot of what we find as a company that works in the commercial spaces, half of it is actually what the analytics do and what they're capable of doing, and then the other half is operationally, when you employ these technologies, how do you avoid a lot of these kinds of situations? Because some of this is something that I can't solve from an analytics standpoint, but I could say, okay, hands up is only on the camera that's looking specifically at the person behind the counter, for example. And so it's not an analytic that we need to run on all of our cameras in our convenience store, for example. So it's a really good point that the kind of operational side and the technology side have to work hand in hand. Because yeah, ultimately you'll end up in a situation where you get false alarms, and it could be that they cause big problems going forward.
Great. I think this answer is is very good, and they will get. So maybe you can a little bit raise curtain about future, what we will see in the future, and maybe you can share with us on what are you working on, and what will be the trends in the security.
Yeah, so actually, really interestingly, we've just been a partner of ours in the US, a company called Eagle Eye, who had their sort of summit, and one of the things they were looking at is the future of AI inside their system. So I mentioned around that kind of reporting and insight, a secondary level of AI. So what we find most of the time at the moment is if I'm generating an event, it's about something that's happening in a particular camera view. And so that camera has no knowledge about what else is happening. If I've got 15, 16 other cameras, I've got no knowledge about what's going on. So let's say, for example, there's a gun goes off in the US and we start seeing lots of people running. It could be that actually that's a good indicator that something has happened, and you want to, you're seeing across all of your cameras this kind of increase in speed, something serious is going on. If you only see that in one camera, okay, it's basically the same across the two events, but it could be that actually the context of knowing that this is happening in 5 or 6 places as opposed to just one becomes really important. And so there's a lot of work going on around, it's not necessarily general intelligence, but it's this concept of aggregating information from lots of different sources to provide insight, from kind of macro from micro, to macro, to say, okay, we're seeing a lot of this type of thing, so this is the action that we need to take. So that's certainly one side of it, a sort of secondary level of scene understanding. And then I mentioned the concept of kind of multimodal LLMs. So the idea that I can put an image in front of a computer and say, tell me what's happening. Now, that's kind of a generative solution as opposed to a predictive. So for us, we train an algorithm. We know that this is a person in a scene. It's only ever going to be a person or not a person, for example. And that kind of binary classification means that we can quite easily create rules on it. If a person is here, do the thing. With the sort of generative stuff, it could be that they will say there's a person walking across the car park, or there's many cars in the car park and it's nighttime. You don't necessarily always know what you're going to get. The example that they gave actually was around if I've got an office and I'm looking for empty chairs because I want to know that there's some space for someone to pitch up and do some work, they can say to the LLM, in this scene, are there any empty chairs? And it might say, yes, there's empty chairs. And that is kind of a definite solution for, with the predictive stuff that we generate, it does one thing and it does one thing very efficiently. With the generative stuff, you have the ability for one model to do lots and lots of different things, and maybe things that you didn't know it could do to start with. You have that sort of variance there. So I think we'll see a lot more of that going forward. The issue with that at the moment is deploying it. So actually running that on the edge is very expensive. You need lots of powerful machines. And so for us, one of our servers can run, say, 90 or 100 cameras on one box. With these kind of generative solutions at the moment, we just can't do that at scale. So that will obviously change in the next kind of 2 or 3 years. GPU power will go up, the models will come down, and so we'll probably get to a point where that kind of thing is viable at the edge.
Great, thank you very much. So maybe we have some additional questions from auditory. Yes, please. I will try. 1 second. We have additional questions.
Hi there, can you hear me?
I can.
So my name is Nils, and the question from my side is basically China is surveilling on their own people, on the citizens, and it's also using the AI. So is there any connection between the technologies that you are using? It's like really quite similar when I look at it with the same, it's just there's no social credit that's collecting. So that's the question.
Yeah, absolutely. No, I mean, it's a really good point. And I think when you're talking about monitoring at this level, GDPR does a lot of groundwork for making sure that those kinds of applications are not abused. So we can do high level monitoring. We never really do anything about you are X and we know that you are X and we can recognize you every time. And there's certainly rules and regulations about that in terms of sort of facial recognition and how we use your biometric data. So no, absolutely, you have to be careful. There is, of course, nothing stopping you training a model. So if you're doing something for kind of age and gender, then the obvious extension for that is things like racial profiling, and that's definitely what we've seen in the Chinese market, especially. So there's definitely companies who've been doing that for obviously legitimate reasons, and I think it's the same argument you'll find with a lot of technology in that it can be used for accurate and reasonable uses, but of course it can be abused as well. And so you have to be careful about that, of course, and that's kind of down to your own motivations. But we take a pretty firm standing in terms of we follow the governmental regulation for the various different areas that we work in. We tend to be governed by the EU and UK standards, even though we work at a worldwide level. So obviously in places like the Middle East and China, the regulations around how we use that data and what we can collect is significantly lower. You can almost do anything you want, but we tend to guide ourselves based on GDPR because it's a pretty good standard. It's been relatively well defined, even in a fast moving technology industry where people are creating new models all the time that can do new things. But yeah, it's difficult. There's unfortunately not an awful lot stopping people do it. So it really comes down to making sure that you as an employer of the technology are doing it in a responsible and fair way. And us as a company, we have to be comfortable that the solutions that we are developing are likewise not abusing human rights or people's privacy in any way.
So thank you for the answer. As I can see, you can hear me. So the question is right now, so it means basically, I'm not saying that the governments aren't using these special AI techniques before. I'm not saying that they weren't using, but like the question is, if the government is asking for your help, it's quite a huge possibility that you will help in any information that you could use this AI technology to help them, right?
So we don't have any government projects in that respect. So we would tend to yeah, I'm not sure I fully understand the question. Is the question if the government was to ask us to assist in developing immoral solutions, would we do so? Is that the question?
Yeah, if the government asks, are you helping? Like it's a simple question.
I would say I can honestly say only within the confines of the solutions that we're comfortable to provide. You know, so if they ask us to develop something that we're not comfortable with, we won't do so. And also, this is not something that you can generate really quickly. You know, these solutions have been developed over 10 or 12 years, and certainly you'll see even at things like trade shows when a new technology comes to market. So one example of that is we see a lot of in the retail space things like theft detection. So you're looking at a person and they're able to determine whether or not somebody's picked something up and put it inside their jacket or a bag. You know, that solution doesn't appear overnight. That's something that takes 2 or 3 years to develop. So yeah, you have to have that sort of motivation and willing to do it for a long period of time. It's not something that's going to, if the government comes along, I need this, and you're going to do it, and we're going to produce it tomorrow. It's something that you have to sort of commit to. Unfortunately, you know, where we operate in the UK, we can't be kind of cajoled to do that. And as I said, we have to make sure that we as a company and ourselves are comfortable with the types of solutions that we're producing, and of course operate within the kind of the confines of the legislation and what's been sort of legally defined.
Great, thank you. And I saw that we have a live question from Netherlands. Yeah.
Yeah, hi, my name is Ben Dommach. I'm a lecturer also, together with my colleague Peter Peters. And we have a question about the time of training a model. Especially in the case we have with retail, we have mobile banditism. Then we get acknowledged about the modus operandi, but sometimes it takes some time to put it into the system, especially also with our people, to train them, to recognize it. But how long does it take to get it into an AI learning model?
Sure. So all of our models are trained offline. So we don't do a kind of online learning solution. So we have an ML team that's based in the UK that has resources to train based on the data that we collect and partner with our customers to provide. So depending on the model, it changes. Our deep learning object tracker, so that solution where I showed you the people walking in the street, that takes approximately 4 days to train on a relatively powerful set of GPUs. And then after that, we've got probably 2 days of evaluating the results from that. So looking at the metrics that are generated, looking at the visual results, whether the tracking looks better or worse, whether it's missing something that we should be detecting or not. So yeah, approximately 4 days, but we would often between a release do a number of iterations on the data set. So with any kind of ML training, it's a kind of rubbish in, rubbish out system. So if I've got a data set that's not representative of my problem, so all of the data that we use to train is all captured from CCTV footage. It's not captured from, you know, really high quality cameras that are used at taking pictures of Disneyland. This is stuff like that kind of really grainy view that I showed on the sort of second slide. You know, so it's very focused on our application, which is CCTV footage, which is, you know, a camera kind of pointed like this at a certain height. So it's very focused on the application. And so even with that, you're looking at probably 5 or 6 iterations of the data to check that we have got, you know, good quality variants. We've got you know, a wide spread of the types of things we're trying to detect. And so although it's 4 days to train one model, it's very likely that we're doing 7 or 8 iterations of that to kind of look at different augmentation steps, you know, different variances on, you know, increasing or decreasing data in a particular set. So yeah, 4 days to train it, probably more like a month to actually look at a new release for a model that we know categorically is better to solve our problem.
Great, thank you.
Thank you.
So give applause and thank you very much, all the speakers, all the guests today for this, I would say, very good, innovative way how to share this information. And let's hope we will manage to do this as regular events. And so thank you and have a good day.
Bye-bye from the Netherlands.
Bye.
Thank you very much.
Thanks, everyone. Bye-bye.